That's probably the most important slide of this presentation because this session would be recorded, slides will be available. And there is like 2 hours version of this talk, not 15 minutes. This presentation is about how to query stream. I came to you from the land of streaming. My name is Victor Gamov. I work in a company called Confluent. I am principal developer advocate there, wrote the book about Kafka, know a few things about streaming and some other interesting things. When we started doing any systems like development with the system, we started with monolithical systems. Usually everything went to the one database, one operational database. Everything was great. Everything was fun. At the point it was not, because we need to start dealing with some external systems. We start bringing some other databases into the mix, bringing data to different places. So that's why the things like CDC and ETL come into play. It allows us to build the pipelines to move data from one operational store into places usually represent some sort of like a data warehouse where we can run bigger analytical queries and we can get the bigger story about our organization. ETL, it's extract, transform, load. We extract the data on the source, transform it, and then load it to some destination. Like I said, maybe the data warehouse, some sort of analytical storage. And CDC allows to extract the data from the source, from the changes that happen on the database, and push it through some sort of streaming platform in order to get this on the other side and materialize it back. And the people start messing around. Distributed system comes into play. One data will not going to fit in one server anymore. Now we need to start dealing with distributed systems and the data pipelines. Microservices come into play, and microservices very quickly require some asynchronous communication, and every road or every service or every data stream led into the world of Kafka. Kafka represented a distributed transactional log where data is captured, is ordered, data is mutable. You cannot change it. That data is immutable. You cannot change it the same way as if you're holding conversation with your significant other, you said something you're not supposed to say. You cannot change that. Same thing with the message in the Kafka. Only thing that what you can do is a kind of issue apology or send another message that would need to be processed on the other side in order to apply this change. So Kafka is great. And it turns out that we need to also, Kafka is great for storage, Kafka is great for moving data around, Kafka is not so great for querying. And there is two types of queries we usually want to implement when we're talking about querying data in whatever source we have. It's one, what I like to call is the OLTP stream. Essentially, every time when you care about individual transaction, you care about individual transaction that happened with your credit card. And OLAP stream, this is where you care more about story. For example, you don't care about individual transactions, but you do care how much money we spent on the groceries last month. Still same data, still operates on top of the transactions that happened on the credit card, but in this case we care about the story. So analytical use case versus operational use case. Now, with this, I would like to propose few tools. Again, with the limit of time, with limit of technology of my time, there's only few that I can cover today. We start with Kafka Connect, which is in brand store for data integration. Streaming SQL, new breed of databases I'm pretty excited about. Real-time OLAP databases, data warehouse or data lake. And at the end, I would like to talk about some technology that we developed at Confluent, and I think you're going to like it, and especially if you are in the Iceberg jazz. So the Kafka Connect, it is a framework that allows you to quickly build integrations with Kafka. You can have a connector that will be listening data at the source, that connector that will be shipping data from Kafka to some sink. So in this particular case, we're going to be interested only in a small amount of data because we will be dealing with moving data from Kafka to some place that we can query. Usually it's some sort of database like a SQL, MySQL, Postgres, Maria, whatever you have. And usually it is focused around transactional data, around the transactional streams and how we can query this. So in a simple use case, we have a data that stores in our Kafka cluster. We have a Kafka Connect service that will be reading data constantly and updating somewhere on the data sync side of things. And we can query this data sync. It's a simple solution and also gives you flexibility to use tools, whatever you already have and know. there would be some lag how the data would be synchronized, so it's not real time, even though it gives you ways how you can query your stream without inventing like new technologies or inventing new wheels. I'm super excited with this new breed of technologies called streaming SQL. And I would like to also propose a couple characteristics that allows you to distinguish what is streaming SQL, what is streaming SQL is not. I would say when I started doing any like software development, I was thinking like, I don't need to learn SQL because I know Java. In Java I have Hibernate, screw SQL, I'm not gonna write SQL. And like 20 years after, SQL is still there, going strong since 1992. SQL for queries, that's the must. Because people either know SQL, but let's face it, we're asking ChatGPT, and ChatGPT writes us much better SQL queries than we can write. Now, streaming service, like a Kafka, Pulsar, Kinesis needs to be the first like level kind of citizen. There would be no connectors. There should be direct ability to create tables out of the streaming sources. And also, sorry, I'll get back. And persistence. So we don't want to reprocess because we already created the stream and query or materialized view, and we want to query this immediately. 3, 4 technologies that I would like to highlight. KeySQL DB, this is something that early on we developed at Confluent, we open source this, and KeySQL DB allows us to develop some of the ideas around how this querying stream should look like. Materialized, it's the partially open source, partially commercial. Rising Waves, also partially open source. There's a great support. There's Time Plus. It's also in another breed. Time Plus is very special because it also has some of the capabilities of real-time OLAP databases as well, because it has a little bit of the ClickHouse. So let me click through this quickly. Some people might ask me, Victor, what about Flink? Anyone heard about Apache Flink? Anyone enjoying using Apache Flink? What? That was quick, okay. So Apache Flink only has like a few capabilities that I just outlined with streaming SQL. Definitely Flink has a SQL that allows you to write stream processing jobs in Flink, but Flink, it is not database. Flink, it can be one of the elements of the engine that you use to power your database. But in reality, Flink is more like a stream processing system. My friend and my colleague, David Anderson, recorded the video. If you are interested to learn why Flink is not streaming database, you can find this at developer.confluent.io or Confluent Developer YouTube channel. I'll give you a second to take a picture. All right. I'm going to skip this. Like I said, slides will be available. I want to go quickly to the interesting points. Now, the materialized view, that's how I envision what the queries on top of the streaming data would look like with streaming databases. I spent some time working with real-time analytical databases, and I think, in my opinion, if you need to build some sort of interesting story and you're okay with moving data around and kind of like moving data between, say, Kafka and this engine, this is actually very close to ideal world, because those systems are designed to be highly concurrent, low latency, so that works for production data. It can ingest data from streaming and batch sources, and also you can do join between those. You have streaming data from one place, and you can get the batch data that join this data after that. Has great support for Kafka, for Kinesis, for Pulsar, and also gives you SQL and conventional tables. Analytical use cases, low latency, high concurrency. Now, let me get back. Cloud data warehouse. Implementation of data warehouse, but stored in the cloud. Now your data will be stored on someone else's computer. They solve the problem of handling data and storing this data somewhere else. Usually not very good source and not very good integration with streaming sources, but it's possible. It's not something that works like maybe out of the box, but it's more like afterthought. Now, data lakes on the other side. This is an interesting technology that allows us to separate two concepts. We're separating concepts of the storage from concept of compute. So the way how we're storing data and how we query data, it would be slightly different. An interesting thing is that we changed ETL in the favor of ELT, kind of extracting, loading, and like whatever. Like whenever we need to read this data, we will figure out this after. And usually it never happens. What started as a good idea, saying that, oh, we don't need to worry about schemas, it turns out to be kind of, you know, the situation like you have a teenager that will be lashing out and you parents don't understand anything, I'm not going to use the schemas. And at the end of the day, we need to have a schemas, so this is how we end up in the world of open table formats, right? So some of the good things came from the world of data lakes is open table formats, and specifically Iceberg, that allows us to still have our compute disconnected from our storage. We have ability to ingest data from streaming source, but now we need to somehow synchronize this job of moving data from Kafka into the streaming source. And this is where Iceberg allows us to take care of the storage side of things. But we still need to deal with this gap between, you know, moving data from an operational place. In my world where I came from, it's usually Kafka. That's where the data lands first. And to analytical space, where we need to query, write reports, and getting some interesting stories. And for a very long time, ETL was only solution. We need to get the data from Kafka. We need to have some sort of connector. We ingest this data into Iceberg. And after that, we can using Snowflake, Databricks, Trino, whatever you have, to query this data. Now, with Tableflow, what we did, actually, we took this concept of Kafka topic and represent Kafka topic in the form of Iceberg table. So let me quickly show you how this would look like if you would be using. I swear God, I didn't plan to talk about floods because this demo was designed like a very long time before this like awful thing happened in Texas. But this demo actually uses information from the British government because my friend Robin, who designed this demo, he actually, you know, Brit. So data about some of the measurements and readings and about the stations that collecting some flooding information available through API and ingested in the Kafka topic in the form of connector that will be listening API of these events. And after that, pushing this inside Kafka topics. Now, with going here and clicking enable Tableflow, in this particular case, this says Tableflow syncing in Iceberg format. Now, my topics immediately represented in the form of Iceberg table inside my, say, let me show you how my Trino application would look like. So I'm using Trino to query this and this very nice UI tool called Popsicle to query and visualize the tools. So all these measurements I can perform in a form of, again, regular SQL. I can do joins between those tables are available, and say, like, I can run some visualization. Pardon my real estate on the screen that is not available for this. So Tableflow allows to have your data in Kafka topics immediately available as an Iceberg table, and you can use whatever tool. If you're interested to try it out today, there's a code, gives you $400 on Confluent Cloud. Is plenty to play around, and after that, destroy your Kafka cluster and never come back. I hope you will come back. Use this code and let me know what you think. Now, usually I say people before I start talking this presentation, I'm not going to give you a definite answer because there's always no right solution or no wrong solution as well. It's always a trade-offs. There's always will be some things that work for you or not work for other people. So sometimes, if you're using something that you already know, for example, you're using your Postgres table to query data from Kafka topic by using Kafka Connect, it's fine, it's okay, it works for you, and if it works for you, it's great, it's not a bad thing. Sometimes you can feel the problem with performance and getting data, or you see problem with latency, getting data from the source and materialize it and see this immediately. That's a problem for some people. Another thing is that important for me personally is that how big is the community where you can ask the question. When I started learning programming, the first language that I learned was Pascal. Not because it was cool, but because I knew the guy who knew Pascal and he can answer the question. Same thing with learning technology. You need to make sure that you have a good community of people where we can share ideas, share knowledge, and you will be welcomed there. That's why I'm asking about Kafka Scala community. Scala community requires PhD to enter. So, sorry guys. Kafka community on the other side is super welcoming, so that's why Kafka gained so much success. So that's why all successful technologies, open source technologies, have a very strong community behind this. Apache Iceberg has a great community where you can ask questions, you can build some stuff. And that's actually a good thing. With this, my name is Viktor Gamov, and as always, have a nice day. I hope you have any questions for me. I will be somewhere around.